Okay, so we are going to finally get to our C notes on weathering, erosion, and deposition. So before we get into the different components, let's review over the definitions. Remember, weathering is the breaking down of rock into smaller pieces that we call sediments. Erosion is a process where the sediments are transported or moved to another location by wind, gravity, glaciers, humans, running water, that kind of thing. And deposition is a process where the sediments are released by their transporting agent, which means they're dropped off. Weathering does break down the rocks, erosion moves the particles, and deposition drops them off in another location. So let's go over the two main primary types of weathering. And this is the new part, and I really want you to write this down. There are two types of weathering. There's chemical weathering and physical weathering. Physical weathering is the breaking down of rocks and minerals into smaller pieces without changing its chemical composition. Like the lab we did today, where we took the sugar cubes and we would shake them back and forth and we would change the size and the shape. That is physical weathering. So physical weathering is when you change its physical appearance, the way it looks. You do not change what it actually is. So roots, ice wedging, all that is physical. Ice going into cracks and making the cracks bigger, that is physical weathering. Exfoliation and abrasion are also types of physical weathering. And so abrasion was one of our vocabulary words that we had to look up for our lab. And it's the scarring, the tearing on the external surface. That is physical. So now let's go into chemical. Chemical weathering is the breaking down of rocks and minerals into smaller pieces by a chemical action. The rocks break down at the same time as it changes its chemical composition, meaning changing what it is. It's making something new. The end result is different from the original rock. There are three types of chemical weathering. The first one is oxidation. This is where oxygen combines with elements in the rock and it reacts. Hence, that reacting is what makes it chemical. So this is a scientific name for rust. Whenever you see metal rusting, that's oxidation. Like the Statue of Liberty. She's green. She's actually copper. But when copper oxidizes, it turns a green color. The second type of chemical weathering is called hydration, and that's where water can dissolve away many earth minerals, including certain rocks. So when water is constantly being exposed to and it starts to break down that rock and weather it away, that is chemical weathering. Now, carbonation is when carbon dioxide dissolves in water and forms an acid. This makes acid rain, which can chemically weather or dissolve rocks. Other acids can also combine with water to make acid rain. So when we have a lot of burning fossil fuels, it does bind with the water in the air as part of the water cycle, which can change the pH, making it acidic, which makes acid rain. So just know that what chemical weathering is and the three main processes. So there are four factors that affect the rate of weathering. Surface area is a big one, which is its exposure. Exposing more surface area will increase your rate of weathering. So let's pretend like this is our sugar cube. We have one whole cube. Then we divide that sugar cube into 8 pieces. We have increased the surface area. Look, so on here you have what? 1, 2, 3, 4, 5, 6 sides on a cube. But then if I break that one cube into 8, multiply 8 by 6, then multiply that by 64. See how the surface area is increasing. The more surface area there is, that is going to increase the rate of weathering. Particle size, large particles are obviously going to weather slower than smaller particles. One of you today actually noticed in the lab that as the process went through with y'all doing the sugar on the physical weathering, it started to erode faster. And the reason was because the particles were getting smaller. And the third thing that affects it is what is the rock made of? Certain rocks and minerals are weaker than others, and some are stronger. That kind of went into that one word that we had about resistant. Some are resistant to weathering more than others, like granite. And the fourth one is climate. Warmer, moist climates have more weathering because the heat and the water speed up the chemical reactions, and it's the most important factor in weathering. All right, so let's talk about erosion, which means to transport, to move. So there are 5 main agents of erosion. Running water is definitely the number one. It's what helped us to form the Grand Canyon, is a running water. Glaciers, wind, gravity, and then sometimes we even throw in humans. I would rather focus on the first 4, which is water, glaciers, wind, and gravity. Weathering has to happen before erosion can take place. There has to be sediments before the agent can move them. So the rocks have to be broken down into sediments before it can be eroded away. Here's an example of wind erosion. Here's an example like this big crater in this mountain is glacier erosion. So let's talk about Mount Rushmore. Okay, do you think Mount Rushmore is going to be there forever? Well, the answer actually is no. There is a pile at the bottom of Mount Rushmore of weathered material. It is slowly being eroded and falling downhill by gravity. So it will not be there forever. You can identify which agent is erosion is transporting each sediment by looking at a few characteristics. So running water, for example, sediments that have been transported by running water tend to appear very rounded and smooth, kind of like river stones. They're very soft, they're very smooth and rounded. That's because of the weathering that's happened as they're tumbling and moving over through the flowing water. Glacier sediments have been transported. They appear to have scratches and grooves like dug out of them as the boulders of the glaciers move. Wind sediments have been transported by wind, appear to be pitted, like they can have random holes, they could have a glazed or a frosted look to them, or in sorted piles. And they also have very small particles. They have to be small for the wind to move it. And then gravity sediments, obviously, that are being transported from like a top to the bottom. Obviously, gravity is the agent responsible for that, like Mount Rushmore. So extreme wind erosion, the big dust storm of 1983 that happened in Texas that you've probably learned about. Rocks to the right were actually transported by running water. So how can we tell? If we look at them, see how smooth they are and rounded. They're not sharp and jagged. Where over here, these are showing glacier scratches. So running water can actually transport things in 3 ways. They can make a solution where if the particles are small enough, they actually dissolve into the water. They could be suspended in the water, or they could be saturated in the water and rolling and bouncing around off the bottom. So we know that if you have a stream or riverbed, there are always going to be rocks found at the bottom. Bed loading is a material that is being transported along the bottom of the stream. Down cutting is when weathering and erosion cut into the water down the side, making the water deeper and wider. That's called down cutting, kind of like the Grand Canyon. So what are 5 ways that humans are making erosion actually increase? Well, deforestation is a big one. When we are removing all these trees, we're cutting down their roots, which is leaving their soil exposed to be eroded away faster. Strip mining, removing the rock cover and the resources below, allow the sediments to be moved by wind, water, and so on. Construction, improper farming, not plowing the land at the right angle is causing the soil to be eroded away. And salting highways. Now, even though we know we need to salt highways like when they freeze over, it actually washes onto the side of the roads and prevents vegetation from growing, which again limits the roots, which holds onto the dirt to stop it from eroding away. So let's go into deposition. We know that deposition is a process of dropping off from your erosion agent. And most deposition happens in standing or stilled bodies of water, like when a river enters into an ocean or lakes. Deposition can occur when water starts to slow down. When it slows down, the particles that are being carried or suspended are going to be released. So 3 factors that include it, like we said, sediment size, the shape, and the density. Do they float in the water? Do they sink in the water? That kind of stuff. Okay, so if we just look at this, we have sorting. Okay, notice that the big particles tend to go to the bottom, and then as you go up, then the particles are going to get smaller. Horizontal sorting, which is where the river is going to enter a lake, is where the big particles are going to be dropped off, because that's where it's going to slow down. And as the stream enters the river, its kinetic energy is going to decrease and it's going to slow down, eventually dropping the bigger to the smaller, to the silt, to the sand, and eventually the stuff that is dissolved. So vertical sorting is when you obviously sort from big to small up. Horizontal is big to small horizontally. So let's talk about a delta. Here you go. Here is a great picture of a delta in the Mediterranean Sea. A delta is a fan-shaped formation of land that is formed from the deposit of sediments at the mouth of a river when it enters a large body of water. This is seen underwater, and the particles are actually horizontally sorted. So we have this river, and it's entering into the sea, so it starts to slow down. As it slows down, it starts to drop the particles, obviously dropping the bigger ones first, and then as you move out, the smaller ones. Well, the water, when it hits it, it moves in all direction, creating this fan shape, or kind of like an upside down triangle that looks like the delta sign in the Greek alphabet. So that's what a delta is. Deltas are always going to be formed from deposition. And here's another delta. Right there. So let's talk about another type, which is an aerial fan. This is the same thing. It's formed from deposition in the streams, but these are not yet underwater and they are very visible. This only happens on land. So if you wanted to, you could call it a land delta. From like landslides or mudslides, again, they make that fan shape. Cross bedding is where layers of sediment are deposited at angles and they result in the changing of direction. So this usually forms in sand dunes, deltas, fans. So here's an example of a rock that's been cut into. You can see how the wind tended to blew when it was depositing in those years, and then it went a lot more horizontal. Okay, so there you go. If you need to rewind, go ahead. But the main thing I want you to understand is the different parts of weathering, chemical and physical, and examples, erosion agents, and how you can tell which one is doing it, and deposition, and knowing that a delta is formed from that. Okay, and I'll see you tomorrow.